Hello, Math 70. Sorry I can't be there today. Going to take a look at section 2.5, which is about compound inequalities. So that's taking two simple inequalities that we've been playing with in 2.4 and putting them together with the word and or the word or. So here I'm going to take x is greater than or equal to 1 and put it together with and x is less than 5. So and means to put the sets together and see what they have in common, or where do they overlap. So the yellow here is my x is greater than or equal to 1, and the pink is my x is less than 5. And I want to see where they overlap. Well, they overlap at 1 to the right, up to 5, but the pink one doesn't use 5, the green one does. They have to agree. So when I put that together here, they both agree on 1 because of the or equal to there, and 1 is definitely less than 5, so that gets a shaded circle. But they don't agree on 5, so that gets an open circle. Otherwise they overlap at everything in between. Now sometimes with and connections you can rewrite it as what's called a double inequality. Remember before I said you always have to read from the variable? So reading from the variable, this says x is greater than or equal to 1 and x is less than 5. And that describes this interval. Now we can also use interval notation. So the 2, why did I put a 2 there? What the heck? Let's erase that and put a 1 in there. Come on, eraser. Oh shit, that's a pen. Let's see, erase. There we go. The 2, and fix it with a 1. There we go, it's better. That was odd. So I can be, the bracket means I can use 1, the parenthesis means I can't use 5, but they're both boundaries. So that's the interval notation version. So there's 3 ways to describe this interval. As a compound inequality, x is greater than or equal to 1 and x is less than 5. As a double inequality, where we read again from the variable, x is greater than or equal to 1 and less than 5. Notice that the way I read this is the same way it's stated right there. And I could also write it in interval notation. So let's solve this compound inequality. So first I have to break each one down to a simple inequality with just x on each side. Okay, so let's see. For the first one I would add 1 plus 1 plus 1, and that's going to give me 2x is greater than negative 2. Then I'll divide by 2, and so I get x is greater than negative 1. Okay, then I have to do the other side separately. So there I would subtract 8 from each side, and that gives me negative x, right, is greater than or equal to negative 7. Dividing by negative 1, I get x is, remember we have to change the direction, less than or equal to 7. Oops, was that off the screen? Sorry. Alright, so then I got to put those together. So let's get a number line. Alright, so this is an and, so we want to know where these two things overlap. Let's say I better number the number line. Let's see, I got to go from negative 1 up to 7. Let me zoom in on this. Alright, so let's say that's going to be negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. So there's 7. Alright, so now I can get rid of that box and do some highlighting. So let's see, let's do pink highlighting. Okay, so I have to be greater than negative 1. So I have a circle on negative 1, and then I want to be greater than, that way. And I need another color, how about green? I want to be less than or equal to, so the closed circle, and then I want to go that way. Alright, so how do those guys overlap? Well, the overlap is this gray area right there. So between -1 and 7, right, and overlap, I can't use 1 because of the open circle, but the closed circle means I can use 7. Okay? So I could write that as a double inequality since it's a contained interval, right? I can't use the arrows on each side. So then I think my answer with interval notation would be parenthesis -1, comma 7 bracket. Or from the variable, x can be greater than -1 and x can be less than or equal to 7. So those are the two ways to state the answer. Interval notation, this one can do a double inequality. So that's with the connection and. Let's try the connection or. Okay, so here I have x is less than -1 or x is greater than or equal to 3. So I did yellow for the -1. Right? So here I can be -1 or less. Open circle, actually I can't be -1. Closed circle, because I could be 3 or greater. Now or means just put them together, don't worry about overlap. So a couple ways to phrase that. Or means x values have to be in one set or the other. They could be in both, but not here. Sometimes they can. I.e., that is, put the sets together. So if I just put those sets together, I get this number line right here. So that would be my solution on the number line. So how do I state that solution? Well, there's a couple of ways. One is the number line. One is to state it the way I have at the top. X is less than -1 or x is greater than or equal to 3. Alternatively, I could put that in interval notation. Now in interval notation I need two groups to describe that. From -1 to the left forever, parentheses on both, union from 3 to the right forever. So this one's a little more complicated. I cannot write this as a double inequality like we did before, and I'll show you why down here. Say I got a pen. If I tried to put x in the middle, well, x here is greater than or equal to 3. X is also less than -1, reading from the variable. Now the problem with that is if you kind of get rid of x there, basically that says -1 is greater than 3, and that's just wrong, bad, no good. So ors usually cannot be written as a double inequality like the and could before. I can either state it like this or I can state it like that. Either way, it's this shaded region on the number line, these two different disjoint regions. Alright, let's try that on this system here. So I have to solve each one individually, and then just or means put them together, whereas and means overlap. So let's switch to red. Okay, so what do I have here? To solve this one, I would subtract 3 from each side. That gives me -2x is greater than 4. Dividing by -2, remember when we divide by a negative we have to change the direction, so that changes to x is less than, in this case, -2. Separate them. This one here, I would subtract 1. That gives me 3x is greater than x plus 4. And then I would move the x to the other side. Minus x. And that gives me 2x is greater than 4. And then divide by 2. And I get x is greater than 2. Okay, and here the connection is or. So let's draw a number line and double check to see what this is. Oops, wrong button. There we go. Number line. So I'm going to put it right across there. I had to zoom in on it a little bit to put some numbers on it. So I need to see from -2 to 2, right? And so here's, oops, where's my pen? Thought I had a pen. -2, -1, 0, 1, 2. And I'll start with my highlighter to help me figure this out. So let's see, what do we have? X is less than -2. So that would be less than goes that way, and it's supposed to be an open circle. Can I erase a little chunk of it? Oops, too much. Try again. There we go. What's the other one? Or x is greater than 2. So that would be here and that way. Alright, let's get rid of the highlighting. Now I want to be able to take one, the other, or both. So there is no overlap. That's fine. So my answer is pretty much like I have it. So I'm going to circle. Let's use blue. This is one way to state the answer with an inequality. That's a picture of the answer on a number line. In interval notation, the answer would look like -2 to the left forever. They both get parentheses. Union 2 to the right forever. Okay, that's it. Go forth and do some good math. Get your homework done. I'll see you on Monday. Have a good weekend.